Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox, where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. Like the video, share it with your friends to get help for anything that you need in middle school math. All right, today our objective is to find the range and the interquartile range for a data set. All right, so let's just jump right into it. In order to find the range and the interquartile range, we got to do a little bit of work with our data before we can even calculate the range and the interquartile range. All right, the range is pretty easy. The interquartile range is a little bit more complicated. Still, mathematically, it's really not hard at all. It's just subtraction. But you've got to find some information first. So before we get to range and interquartile range, I want to start with just talking about the 5 most important values or numbers in data analysis. All right. Whenever you have a list of data, all right, which is just a bunch of answers to a quantifiable question, all right. Of that data, you've got 5 numbers that are more important, that are the most important for data analysis. 3 of the numbers are pretty understandable, all right? The lowest number in the bunch, the highest number in the bunch, and the middle number in the bunch, all right? Those are 3 of the numbers, but then the other 2 are kind of halfway in between those 2 major sections right there, okay? You've got the middle of the lower half and the middle of the upper half, all right? Together, these make the 5 most important numbers in data analysis, all right? They also have names, all right? So we call the lowest value the least. The middle of the lower half we call the Q1, or the quartile 1. All right, that's where the first quarter of data ends. All right, and then you've got your median. That's the middle. Then you've got your Q3, that's your middle of the upper half, and then you've got your greatest value, which is the highest number, all right? So those are the 5 most important numbers in data analysis. Again, the Q stands for quartile, the word quartile, which kind of sounds like quarter, and if you understand what a quarter is, you know that's 1/4 as a fraction, it's 25% as a percent, all right? So Q1 is quartile 1. That's where 25% of the data ends, all right? So it starts at the least, and then the first 25% ends at the Q1. The next 25%, which would represent 50% of the data, all right, would end at the median. Then 75% of the data would end at the Q3, and then obviously 100% of the data ends at the greatest. So again, Q1 means quartile 1, Q3 means quartile 3, and the definitions of those are listed right here. Q1 is the middle of the lower half, and Q3 is the middle of the upper half. And that'll make a lot more sense when we kind of start working with this, all right? I call them, for silliness anyways, the lucky muck you go, all right? Because a lot of times we have to find these 5 numbers, and just to make it really simple and straightforward for my students, I just call it something silly, like the lucky mucky gun. La is the least, Q, ma is the median, then you got the Q3, then you've got G for the greatest, all right? It's a whole lot easier for me to say that than to say, I need you to find the lowest value, the middle of the lower half, the middle number, the middle of the upper half, and the highest number, all right? Instead of saying that, it's okay, you got to find the lucky mucky G first, and then we can find whatever it is that we're trying to find, like the range or the interquartile range and so on and so forth, right? So that's what they are. That's what the 5 most important numbers are, and this is kind of how you find them. All right, so here we have an example of some data, all right? Each of the 10 students in Mr. Finn's honors math class was asked how many hours a week that they spent studying, and there you go, those are responses, all right? You've got 10 different students with 10 different numbers for how long they study in any given week, all right? The first thing that you want to do when you're finding the least, Q1, the median, the Q3, the greatest, or you're finding the interquartile range or the range, or just about anything in data analysis other than the mean. The mean is the average. You got a whole different process for finding that. If you don't know how to find the mean, I've got a video already uploaded that you can search for. Just look for the one that says the measures of central tendency, mean, median, and mode. It'll tell you how to find that. But just about everything else, the very first step that you need to take is to take these numbers and to order them from least to greatest. That's the first thing that you want to do with any set of data, all right? Is order them least to greatest. And once you do that, filling in these circles, all right, for the least, Q1, median, the Q3, and the greatest, becomes a whole lot simpler. Okay, so the least is the 3, the greatest is the 12. That's pretty simple. Those are the easy ones to find. Then you can go through your process to find the median. The process that I use, I scratch off the first and last, the next first and last, next first and last, until I come down to 1 or 2 numbers in the middle. If there's 2 numbers in the middle, you got to add those 2 numbers together. Then you're going to divide by 2, and that's going to be your median. All right, so in the process, while I've been talking, you can kind of see there on the screen, we found that 6 and 7 were in the center, all right, the middle. The reason why there's 2 numbers in the middle instead of 1 is because there's 10 numbers in the data set, and that's even. Anytime you have an even numbered data set, you're going to have 2 numbers in the middle that you need to average together. So add them together, divide by 2, and that's your median, all right? Then, when you go to find the Q1 and the Q3, once you have your median, all right, so if there's 2 numbers in the data set, I put a line in between right there. That represents what the median is, okay? Then I'm going to go through and I'm going to circle the lower half and I'm going to circle the upper half just like that. All right, that kind of helps me kind of isolate the numbers into their individual parts. All right, it kind of gives me an ability to focus without, accidentally duplicating any numbers. So I encourage you, once you find the median, if there's 2 numbers that you had to find that between, draw a line. It's going to be a little bit different with an odd number data set. All right, but when you have an even numbered data set, draw a line in between the 2 numbers that are in the middle. That's your median. Then split off your lower half and your upper half. Right? Then, if you remember from the last slide, the Q1 is the median or the middle of the lower half. So we're just going to kind of focus on the lower half of numbers, and we're going to go through the process that we need to go through to be able to isolate the middle number. All right? In this case, there's 5 numbers in the lower half. 5 is odd. And therefore, if it's odd, you're just going to have 1 number in the middle, all right? So once I scratch off the first and last, and the next first and last, I'm going to come down in the middle. I'm going to circle that, all right? That's my Q1. So the middle number of the lower half is your Q1. And then you can do the same process to the upper half. Scratch the first and last, the next first and last, and then you can come down to the middle number in the upper half as well, and that's going to be your Q3. All right, so the lucky mucky guy in this is 3, 5, 6.5, 9, and 12. All right? All right, so I want you, based upon all that, to go ahead and try this one at home. You can go ahead and pause the video, and then once you've done it, you found the least, Q1, median, Q3, and greatest, come back to see if you got the right answer. All right, the first step is to order these numbers from least to greatest. So it says list below shows the shoe size for 8 students in Mr. Perdito's class, and you've got all of them listed right there. The first step is to take those numbers and list them least to greatest. Then you can start filling in. The boxes. All right. So we've got 8, 9.5, 10.5, 11, 12, 12, 12, and 13, just like this. I'm going to switch to making this a little bit bigger. Okay. All right. So I'm going to go ahead and draw my 5 circles down here. That's going to represent my lucky mucky go. All right. The least value is 8. The greatest is 13. That's pretty simple. Then I'm going to go through here and I'm going to scratch off the first and last, the next first and last, the next first and last, and I've come down to 2 numbers in the middle, all right, which means I've got my median right in between those. In order to find the median between those 2 numbers, I'm going to add those 2 numbers together. So 11 plus 12 is 23. So 11 plus 12 is 23, and then I'm going to divide that by 2, all right, and that's going to be my median, all right. Halfway in between 11 and 12 is 11.5. So I'm going to put that number right down here inside the where the median goes, all right? Then I'm going to circle my lower half of data, and I'm going to circle my upper half of data, all right? And I'm going to scratch off the first and the last, all right? And then I've come down to two numbers in the middle, all right? I'm going to take those two numbers right there, I'm going to add them together, and then divide by 2, and that is right in between those my Q1, all right? And then I'm going to do the same thing over here. Scratch the first and last. I've come down to two numbers in the middle. If they're both the same number, then that's the number, all right? So you've got in between 12 and 12 is 12, all right? Or you could do, if you wanted to go through the process, you could do 12 plus 12 equals 24 divided by 2 is 12, all right? And that's my Q3, okay? All right, so I've got my least, Q1, my median, my Q3, and my greatest listed right there. All right, let's go to the next one. Why don't you try, before we go to the next one, there's something that we need to talk about, okay? If you notice right here, this is what it looks like to work with an even numbered data set. And what I mean by that is in the data set, there's 1, 2, 3, 4, 5, 6, 7, 8 data values, all right? And 8 is an even number, so therefore I know that when I go to find the median, I'm going to have two numbers in the middle that I'm going to have to add together and divide by 2, all right? If you need more explanation on that, you can also find that Measures of Central Tendency video, and I talk about finding the median there as well, and I kind of talk about these points of an even number data set and an odd number data set, all right? So you can go look for that video, you can watch that as well. But an even number data set, this is what it looks like, all right? It's a little bit different for an odd number data set, all right? What if I took these numbers right here and I eliminated the 8 off of there, all right? I'm just using the same data set right there, but I erased the 8, okay? Now I've got just 7 numbers, all right? So let's just call this a new data set, all right? And in this data set, I have 1, 2, 3, 4, 5, 6, 7 numbers. 7 is odd, all right? So this is an odd numbered data set. And when you have an odd numbered data set, you're only going to come down to one number in the middle. And when you come down to that one number in the middle, that is the median. So for this right here, that number right there, 12, for this data set, that number right there is going to be the median, all right? Because there's 3 numbers below it and there's 3 numbers above it. That's in the middle, okay? So that's your median. Now then, we're going to go through and we're going to make this point real quick. You can see it right there. In an odd number data set, the median is the middle number, all right? This is the next sentence. This is the important one that I want you to focus on, the one that's italicized, all right? It says the median itself is excluded from both halves. So one half contains all the values below the median, and one half contains values above the median, all right? When you have an even numbered data set, you put a line in between the two numbers in the middle, add them together and divide by 2. When you have an odd numbered data set, you circle the median, okay? But in both instances, all right, up here the median was 11.5, down here the median was 12. In both instances, you are not going to include the median in either your lower or upper halves. So this is the way that I want you to do it when you have an odd numbered data set, all right? You're going to circle the median, all right? Instead of putting a line in between them because there's 2 up there, this one just has 1, so we're going to circle it. That's the median. And by circling it, we understand that that's kind of isolated, all right? Then we're going to actively go and circle the lower half, not including the median, and then we're going to circle the upper half, not included the median, just like that. Okay, so this is what it looks like. That's what the process looks like with an even numbered data set. And this is what it looks like with an odd numbered data set. All right, then you can go through and fill in your lucky mucky go. All right, so the least is 9.5, the greatest is 13, the median was 12, the Q1 would be 10.5, and the Q2 would be 12. All right, so there's your lucky mucky go right there. All right, and also notice that sometimes with data sets you'll have 2 numbers, or 2 of the values that repeat the number, all right? That just means that the data is probably pretty close together, and so you're going to have some of the same numbers be, in this case, your median and your Q3 are the same number. That's because there were 3 12s up here, all right? Quite a few responses, so you kind of see the data is kind of condensed right there, all right? Pretty close together. Okay. With all that explanation, see if you can try this next one. All right, go ahead and pause the video. I want you to find the lucky muckuga, all right, the least, the Q1, the median, the Q3, and the greatest, all right, from this data set. Okay, if you haven't paused already, go ahead and do that. If you have, here's the answers. We're going to start with ordering these from least to greatest, all right? And then once we do that, we can easily fill in our least and our greatest, 33 and 72, all right? And then if we, scratch off the first and last, the next first and last, we're going to come down to the middle number, and there's only one number in the middle, and the reason why that is because you have an odd numbered data set. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 data values, all right? So you're just going to come down to one number in the middle. It's that 42. Okay, then you've got a lower set of data, which is 33, 48, 41, and 41, these 4 numbers right there. So you're going to come down to 2 numbers in the middle, the 38 and the 41. When you add those 2 together and divide by 2, you get 39.5. And then your upper half of data includes these numbers, the 57 through 72, all right? When you scratch off the first and last, you're going to come down to 2 numbers in the middle, 60 and 68. Add those together, divide by 2, you'll get 64. And the lucky mucky up there is listed out there in front of you. So if you didn't get one of those right, then go back, listen to the explanation, and see if you can try that again. All right? All right, one last one to try. The following data set represents the number of minutes callers have to wait in line for Netflix. And you see, a frequency table there. So you've got the number of minutes listed up here. That's not the data, all right? That's just the value of the data. And then you've got all these little tick marks down here below and the frequency right here. That's the actual data. So the first step is to list the data, all right, from least to greatest. Don't try to find the lucky muckuga of the number values. Try to find it of the data, all right? So I've got 5 4s, so I listed out the 5 4s, 1 5, 2 6s, and so on, all right? So I listed out all the data first, all right? Now then, pause the video, find your lucky muckuga, and then come back to see what the right answers are. All right, the least and the greatest are 4 and 9. The middle is going to be in between the 5 and the 6 right there because there's an even numbered data set, all right? So in between 5 and 6 is 5.5. All right, then you've got the lower half of data and the upper half of data, all right? So if I were writing this out, it would look like this. All right, 1 second, there we go. The middle would be in between those 2 numbers, all right, which was the 5.5, that's your median. Then you've got your lower half and you've got your upper half of data, okay? Then you've got the middle, the lower half is in between those 2 numbers, but they're the same numbers, so both of those are the same number. You can add them together. That's 8. Divide by 2. That's 4. Okay? So if you're finding a number in between 2 numbers that are the same, it's going to be that same number. Right? Then we're going to get the middle of the upper half. It's going to be in between 8 and 9. Halfway in between 8 and 9 is 8.5. Or you could add them together. 8 plus 9 is 17. 17 divided by 2 is 8.5. And so there you go. You found the Q1 and the Q3. All right? Okay, so now then, we have found the 5 most important values in data analysis, all right? Once you find those 5 most important values of data analysis, you can do all sorts of different things with them, all right? You can find the range, you can find the interquartile range, and so on and so forth, all right? Here's just another set. If you want to try this one, you can, all right? I've ordered this least to greatest right here. And then you can pause the video, you can go try it, and you can come back to see what the right answer is. All right, for this data set right here, the least, the lucky muckuga is listed there. The least was 54, the greatest was 76. The median was in between that 68 and 69, all right? The median of the lower half, because there's an odd numbered data set, in the lower half, you've got, one number in the middle, that's your 62. And then in your upper half, you've got the 69 through 76 right there. In the upper half, the median is going to be the 72 right there, that middle number. Because there's 7 numbers in the upper half, that's odd. There's going to be 1 number in the middle, that's the 72. All right. Okay, so that's how you find the 5 most important values in data analysis. Now, how are we going to use them? Let's find the range and the interquartile range, all right? The range is really easy to calculate. It's just tricky to remember. Sometimes there's so many different things in data analysis you got to remember. So, right, the important thing is just to remember the definition, all right? So a range, the definition is distance between the least and the greatest values, all right? Distance is always the absolute value of the subtraction between the greatest and the least, all right? So what you're going to do first, whenever you're finding the range, is order your numbers least to greatest, all right? Then take your greatest minus your least, and that's your range, all right? So for this data set right here, you've got these data values, all right? And then the greatest is 7, the least is 1, so subtract those and you'll find the range. The interquartile range is pretty similar, all right? It's still a range, and so it's still going to be a difference or a distance between 2 numbers. But the interquartile range is not the distance between the greatest and least. It's the distance between the Q3 and the Q1, all right? So you're going to find the absolute value of the subtraction of those 2 numbers. So again, to find the interquartile range, the first thing you need to do is find the lucky muckiga, all right? You need to be able to locate what the Q1 and Q3 are so that you can be able to subtract them. So you've got to go through this process of identifying where your median is, where your lower and upper half is, go through the process of finding your Q1 and your Q3, all right? So that was all the illustrations you just saw was the process for finding the Q1 and the Q3. All right, once you find the Q1 and the Q3, subtract them, all right? And that's your interquartile range. So not incredibly difficult. It just, just requires you remembering what it is, all right? So the range is simply the greatest minus the least. The interquartile range is Q3 minus Q1. So you're going to have to do a little bit of work to be able to locate Q3 and Q1, and then you just subtract them, and that's the IQR, all right, or the interquartile range, all right? So with the example that we just we just saw, the last example that we worked on was this example right here. Joey Chestnut has won 14 of the last 15 Nathan's Hot Dogs Eating Contests, and the amount of the hot dogs he ate are given right here, all right? So that's least to greatest right there, 14 of the 15 years. This is how many hot dogs he ate to win the championship. All right. Once he won the championship, we can take those numbers and we can order them least to greatest. That's the very first thing you want to do when you're trying to find just about anything in data analysis. All right. And then we can go through and find the range and interquartile range. All right. In order to do that, to find the range and interquartile range, the first thing you've got to do is find the lucky muckiga. All right. So you're going to take your numbers, order them least to greatest, and then go through your process to find the least, the Q1, the median, the Q3, and the greatest, right? Once you do that, I like to connect the first and the last, all right, in this big arch, okay? And then I like to connect the second and the fourth in this little arch, the next 2 on the inside. And I call this tool a data rainbow, all right? It's a tool that I developed. And it just is just kind of a catchy way to remember the 5 most important values in data analysis and then what you can do with those, all right? So you take 76 minus 54, that's going to be your range, all right? So your range, again, is the distance between the greatest and the least. So you're going to take those 2 numbers, subtract them, all right? And you'll find out what your range is. And then your interquartile range, once you find the Q1 and the Q2, all right, you take those 2 numbers and you subtract them, and that's your interquartile range. All right, so for the data set that's listed up here, the lucky muckiga is 54, 62, 68.5, 72, and 76. Then you create an arch for the big range, and then create a small arch for the itty bitty range or the interquartile range, and then you subtract those 2 numbers, and that's going to give you your values for range and IQR. All right, why don't you try, this one right here. So for this one right here, I want you to go through. I've already done a lot of work for you. Okay, so I already listed it least to greatest, you see. Okay, and then I've already given you the lucky muckiga. All right, so all I want you to do is find the range and the interquartile range. Go ahead and pause the video, try that, and then come back to see what the answer is. All right, the range here is 121 minus 1. All right, that's the difference between the greatest and the least. That's going to be 120. And the interquartile range, or the itty-bitty range, all right, is the difference between Q1 and Q3. So we're going to take those and we're going to subtract them. 81 minus 9, that gives us 72. So the interquartile range for this data set right here, which represents the runs scored by a cricket match of 11 players, all right, from this data set, that's the range in IQR. All right. Now let's go on and let's kind of use some different data representations to kind of help us out a little bit. All right, we'll just do one data representation. That's a dot plot. And the reason why I start with a dot plot is because it's the easiest data representation to understand. All right, the dot plot consists of two parts. One part is the number line that tells you the value of the data, and then you have the actual data set. All right, the number line, all right, is not the data. It's the value of the data. So don't go through and start listing the numbers in the number line. All right. What you want to do when you're finding, data analysis, conducting data analysis from a dot plot, is you want to kind of like focus in on the actual data, which are all the dots above the number line. And you want to take those and you want to list them from least to greatest. All right. So I had 1 0. I had 3 1s. You see those 3 dots right there? That means I have 3 1s. I have 4 dots above the 2, so I've got 4 2s. I've got 2 3s, a 4, and a 6. So when you're finding the range and interquartile range from a dot plot, you can first go about ordering your data from least to greatest. All right, and then you can start working through your process there. The least is 0, the greatest is 6. The median is going to be in between those two 2's right there. All right, so they're both the same number, so the median is 2. I'm going to circle my lower half of data. All right, the median is going to be right here in between those 2 1s. So the Q1 is a 1, and then I'm going to circle my upper half of data, all right? And the median is going to be right in between those 2 3's right there, which is a 3, all right? So the least, Q1, median, Q3, and greatest are listed here. Now then, I could take the big arches, all right? 6 minus 0 is 6, and 3 minus 1 is 2. So 6 is the range, and then 2 is the interquartile range. All right, just like that. All right, let's try one more. You try this one by yourself, and then we will be done. So go ahead and take this one, pause the video. What I want you to find is the range and the interquartile range. So pause the video, try it yourself, come back to see what the right answer is. All right? Okay, so if you've done this already now, you should have listed all of the data in order from least to greatest from the dot plot, all right? So I'm taking the data and I'm listing it here. Now, a really good idea once you list out all the data is to count how many pieces of data you have that you wrote out and compare that to how many was in the original question. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, and I'm going to go up and count these dots now up here as well. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 dots. So chances are, if you wrote down 9 numbers and you had 9 numbers in the original list, chances are you wrote down the right one. Okay? All right. Now I need to be able to find the lucky muckiga, the 5 most important values of data analysis, all right, in order to be able to come up with the range and the interquartile range, all right? So I can go through my process here to start finding those numbers. The least and the greatest are the easiest to find. All right, then we've got 9 numbers, so we're going to have one number in the middle, because 9 is odd. It's an odd number data set. We'd scratch off the first and last, next last, and so on and so forth until it came down to one number. That's my middle number. Then I'm going to take this, I'm going to circle my lower half, and I'm going to circle my upper half, just like this. And the middle of the lower half is going to be in between those two numbers because there's two numbers left in the middle, right? In between 14 and 15 is 14.5, right? Or if I added them together, 14 plus 15 would be 29, and then divide that by 2, you're going to get 14.5. Okay, and then the middle of the upper half is going to be in between those two numbers, because if I scratch off the first and last, I come down to two numbers in the middle. Halfway in between 16 and 18 is 17, so that's going to be my Q3. All right, so we've got the Lucky Mucky Go right there listed out. And then to finish the data rainbow, we want to take 18 minus 14, that's 4. And we want to take 17 minus 14.5, that's 2.5. So 4 is going to be your range, and then 2.5 is going to be your interquartile range. Right there. And those are your answers. All right. If you have any questions about this, you can write those in the comments down below. I hope you have a great day. We'll talk to you soon.